Hello, my name is Paul Bevan from Siemens Digital Industry Software, and in this demonstration you're going to see how you can utilize NX Realize Shape to reverse engineer an organic shape that's been developed using generative modeling, such as Topology Optimization. Now, the result of an NX Topology Optimization is a convergent body, and that means I can use it directly for many downstream processes. I could continue to model and add features to the convergent body. I can use it for manufacturing or structural analysis. We can add model-based definition information to it. We can even include it and dimension it in a drawing. So there's a lot of benefits and advantages of convergent bodies inside of NX. However, there could be occasions when you want to use the convergent body as reference and then re-engineer a new design from it. And this is the case for this demonstration. So in the graphics window, I have a part that's made up of two major features: a convergent body, which is the result of the topology optimization, and also a subdivision body. And it's this subdivision body that I'm going to continue to edit and modify to help me re-engineer a brand new part using the optimized body as reference. So let's get started. The first thing I'm going to do is to activate the subdivision body. Now, the part is symmetric, so symmetric modeling has already been switched on. And that means I only have to design one half. The other half is automatically created for me. Now, to quickly define the shape, I'm going to use section tube inside of Realize Shape. Section tube is an extremely fast and efficient means of generating solid geometry based on a reference body. Here you can see me selecting the convergent body, and as I select along the convergent body, the subdivision geometry is being automatically created based upon the section of the reference body at that particular position. You'll also notice that with symmetric modeling switched on, I get the other side for free. I'll continue to add more detail to the subdivision body. In this top area of the component, we'll do something similar, picking on the convergent body again to generate the shape. So I've generated 4 separate bodies and I want to connect them. So to start with, I'm going to modify the continuity. I'm going to select the control cage faces, as you can see, and change them from a smooth to a sharp continuity, as you can see. And then finally, I'm going to project the same cage faces to the central plane. And on doing that, I've connected both halves of the model together. So how close to the original reference geometry is our subdivision model? Well, we can use some of the analysis tools inside of NX to take a look. In this case, we're going to use the deviation gauge. And I select a number of the faces that we've just created. I can then also select the convergent body as the reference, and I get a color coding telling me how close to my original design my new subdivision model is. It stays dynamic, so if I want to go into the editing tools inside of Realize Shape, I'm going to transform this cage, and as I scale those cage faces up and down, you can see the color map change, telling me how close or far away I am from my original data. And I can bring back the legend to verify that. So let's continue to generate our shape and see how we can connect the other areas of the model together. I'm going to start by modifying one of the subdivision bodies we've just created. We're going to make it more editable. We're going to increase the number of vertices and cage faces. That's going to give me more flexibility to generate my design. You can see I can dynamically move the faces before creating them. Just going to drag out the end of that subdivision body as well. And now I'm ready to create one of the arms of the component. And to do this, I'm going to use section tube again. So we select the reference geometry, and again, as I select along the reference geometry, the arm's being created. And when I get to the area that I've just modified, I can select the cage face, and you'll notice that the two separate subdivision bodies have been merged or morphed together. Now let's take a look at connecting one of our existing subdivision bodies to the new one we've just created. I'm going to merge these four faces together to create one single one and use bridge face to connect the two. I picked one cage face and then the second cage face, and it's as easy as that to connect the two separate pieces of geometry. So how about the lower arm? Well, we can go about constructing it in the same way. We'll merge these four faces, and then we'll use section tube to generate the arm. Again, we select the reference geometry, construct the arm, and when we get to the last section, we'll choose the face that we've just merged, and again, the two separate subdivision bodies are connected together. So I'm going to continue to modify the subdivision bodies just using standard realized shape editing techniques, pushing and pulling cage faces. We're going to use more section tube again to quickly generate some geometry. We'll use split face again to add more control geometry to the subdivision body, and then we'll use bridge face to connect the upper and lower arms to this new section. Once we've got that, again, we can use the transform command to start pushing and pulling the subdivision body so it closer matches our reference geometry. It's very simple, very straightforward to do. Here I'm just going to modify the position of the manipulator before I start to change the shape of the subdivision body, and just using similar techniques to morph the shape closer to our original reference geometry. And it really is quick and interactive to do that. So I've still got a little bit of work to do to complete this area of the model. Again, I'm going to use section tube, and again select areas around the front of the model, generating my subdivision shape, and utilize the bridge face command to connect the separate areas together. There's the first one done, and we'll do the second one. And again, to complete this portion of the design, I'm going to use the transform command to adjust the shapes to closer match the reference convergent body. And I'll continue to do that on other areas of the model. Again, just picking up individual cage faces, using the manipulator to drag the shape. You can select multiple faces in one go to make manipulation of larger areas of the subdivision model easier. And there we have the basis for our shape. Now we could continue using similar techniques to refine the model further, but I think you understand the process. So I'm just going to hide the convergent body and see exactly where we are. You can see there's still some work to be done to connect all of the separate bodies, but I think you've got the idea of how we would achieve that from what you've seen so far. So let's take a look at a completed version of the model. Here you can see that we've done further refinement to the subdivision body so that it more closely matches the reference geometry. And we've also added standard NX features such as holes, chamfers, and extrudes to complete the model. So that's the end of the demonstration, but let's just recap what you've seen. We started off with a convergent body that had been generated from Topology Optimization, and we used this in conjunction with the very powerful tools inside of NX Realize Shape to very quickly re-engineer the part. I'd like to thank you for your time and attention.